So section 3.4 is called measures of position, and we're basically talking about something similar to the place a car could get in a race, like first or second. And here's an idea that measures position called a percentile. And a percentile of a set of data is the value such that a certain percent, which we're calling K right here, of all the observations are less than that value. This is another definition that can really apply to a population as well. And we'll probably use it almost half and half to refer to populations or samples. So like most things, it might be easier if we think about an actual number instead of this weird K. Let's say you are the 12th percentile of a set of data or a population. That means that 12% of all the observations or the population are, or is, if we're talking about the population, less than that value. So what does that mean? Well, for example, here you are, this is you, and your height happens to be the 12th percentile. So what does that mean? That means that 12% of all people are shorter than you. We got some short people here. And that the rest of everyone else is taller than you. These people are going to get tall. So if there's 12% less than you, that means 88% of people are taller than you. So if your height is the 12th percentile, you're not incredibly tall. You are only taller than 12% of people. We haven't talked about what value that might be. If you were a woman, say, that might be something like 5 feet tall. But the important part is that whatever your height is, if your height is the 12th percentile, then you're kind of low on the spectrum. This is a measure of position. Just like first or second, your percentile is your position amongst everybody else, either in the population or if we're talking about a set of data. So here's an example of a type of problem called interpreting a percentile, which basically just means talk about what it means. So here's a test called the GRE, and this one particular school, the University of Pittsburgh, requires a GRE score of no less than the 70th percentile for admission into some fancy genetics program here. They're giving us a source, which is kind of nice. And so it says, interpret this admissions requirement. So it says it requires a GRE score of no less than the 70th percentile. That means you have to score better than 70% of everyone that took the GRE. So that's an interpretation of what this means. It sounds fairly challenging, really. You can't just be average. You have to be a full 20% above the middle. You have to be better than 70% of everyone. And sometimes we might make a picture of this. We're going to be using percentiles a lot with distributions. And so I might draw something like, hey, here are the GRE scores, and here's your score. The GRE scores are on the x-axis. Your score is this particular spot on the x-axis. And again, you always want to interpret the vertical axis of these drawings to be something akin to being the count, but instead we call it something fancier. We call it the density, if it's one of these smooth curves. If this is your score, then what they require is that your score is better than 70% and worse than 30% at least. You have to score in this range here. Because if you weren't in that range, then you wouldn't be at least the 70th percentile. That's another way we could interpret it too, is that you must be at least the 70th percentile. Try to remember that percentile equals the percent below. If you are the 70th percentile, 70% are below you. If you are the 20th percentile, 20% are below you. And when I say you, of course, I just mean any value. This could be the weight of your grandmother, or this could be the miles per gallon of the car that you just bought. If the car that you just bought's fuel economy is the 35th percentile, that's not very good. 35% of cars are worse than it, but everybody else, 65% is better than it. And there are a few percentiles that are important enough that we give them this fancy term called quartiles. And you think quartile, and hopefully you might be thinking something like quarters, like there are 4 quarters in a dollar, which means that you have, basically you're talking about splitting this thing up into 4 parts. And so the first quartile, I took out some stuff here, is just the 25th percentile. And sometimes we call the first quartile Q1. I believe your calculators, these TI-83s and TI-84s show it that. There's Q1 sitting there, and it's the 25th percentile. And there's a second quartile as well. And I'm going to get rid of this part. I feel like it's just unnecessarily confusing, because all the second quartile is the median. Just know that they're the exact same thing. Half the data below it and half the data above it. And then the big shocker here, the third quartile is going to be the 75th percentile. There's just a lot of extra words here that we don't need. The third quartile is the 75th percentile. So just to recap really quickly, the first quartile is the 25th percentile. The second quartile is most likely going to be referred to in this class as the median, but the third quartile is the 75th percentile. So these 3 numbers just give us a way to split up either a data set or a population into 4 equal parts. Just like percentiles, they are percentiles. The quartiles are just a specific type of percentile, which, like we said, is a measure of position. We're talking about where in our data set or where in our population are specific values lying.